Okay, my name is Diego Fonstead. I have the fun title of Resident Tinkerer at Castellea School. Our model for our Makerspace has been to try to integrate making into existing classroom experiences. So our function in the Makerspace is more of a consultative function with teachers. We work very closely with teachers, designing authentic experiences that use our space and leverage the different tools of our space into the classroom. And so we spend a lot of time developing and brainstorming with teachers and finding ways of integrating hands-on learning experiences into the classroom. So that's the high level of what we do. I think the range of projects very much varies quite a bit. I think a lot of people immediately anchor on very open-ended projects when they think about what you can do out of a space like this. We tend to go a full spectrum from more prescriptive kind of kits, having kids assemble something and then try to extend upon it, to projects where they are more open-ended builds. An example of a kit project, I don't have it assembled here, but this is actually a kit that you can assemble into a microscope that is used by 7th graders to learn how a microscope works. It's a relatively prescriptive build. It's done in the classroom, but in the process, the students understand the components of a microscope. They can troubleshoot it, they can make it work better, and then when they get to the classroom microscopes, the teacher has noticed a significant improvement in their ability to do their own troubleshooting and understanding of what's truly going on. Before, there was an online project, kind of software that they would use where you would click and get through the different steps of learning what the parts of a microscope are. But most of the students were basically doing pattern recognition and getting through that online thing without really knowing what was going on. But by building one themselves, they got to do much more. Kind of in contrast, this is an example of an 8th grade American history project where the students in teams of 3 and 4 had to design a monument to propose for Monument Mall in Washington. And this one is of Maya Angelou. That's why there's a caged bird on the tree. And so they had to design it and come up with their logic and put it together, but building it. And this is 8th grade history. And there's more here, but we can.
Hi, I'm Sally Garza from Lawrence School in Ohio. We have a small makerspace in our school where we do have a 3D printer, 3D pens, and we run it primarily as an extracurricular club for our 5th through 12th graders. And for the kids who are interested, we get them started with the basics of designing and using the tools. And it's interesting how they have taken it and then utilized it in their own classrooms as independent projects. A few of our teachers are then seeing that, ooh, that's a good idea, and then wanting to do projects whole class, which has been developing our program. Our teachers already have maker spaces in their classrooms for our science and math and some of our other classes as well. So this is just kind of a layer on top of that for them. So most of our classroom teachers will do things with paper and styrofoam and boxes, all in the classroom instead of having dedicated space in the school. So adding the 3-dimensional and design tools on top of that has rolled over to our engineering clubs or robotics clubs, Lego clubs, Destination Imagination clubs, so that they're actually using the skills then across the school.
Hello, I'm Patrick Neary. I'm the manager of the Innovation Lab, the iLab, at Seacrest School in Half Moon Bay. If you care to see a nice beach, please come down to Half Moon Bay. It's a wonderful place. I have a couple of examples here. I have the 3D printer going down at the end. So once you have a 3D printer established and going, what can you do with it? We have about a 30 by 30 foot makerspace that has all kinds of activities at all grade levels. It's a K through 8 school. A collaborative with my history, one of the history teachers at the school. She wanted to do something engineering-wise with a collaborative project in mind. So we came up with a small-scale Roman aqueduct. So I'm printing more of these. I still have a few more to go. So for example, we'll have 18 students each receive one of these 3D printed Roman aqueducts. We'll then assign them the task of allowing water to go from student 1 to student 18. Don't spill a drop. How are you going to connect it? We give them a big block of foam, for example, and then they have to kind of cut the foam themselves. So it's a very tangible result of a 3D printed project. Collaborative, we'll see how it goes. Please make sure water doesn't squirt out the sides. It's pretty interesting. On the other end of the spectrum would be individual projects by students. One of the science classes said, let's conceptualize and model an atom. So this is a neon atom. So in the program SketchUp, which is a free program, free is great, I love free. A student can do this at home if they want to, or we have laptops in the iLab for them to also work with SketchUp. So he modeled a neon atom and brought it to me, and I printed it for him. So this has some support structure. The actual model would be free of a lot of this support material. Come on by, I can tell you more about this. Here is a spindle that supports the filament. So in the spirit of a DIY, do-it-yourself movement, rather than order this spindle to fit on the back of a MakerBot to support the filament, let's make it ourselves. So in Tinkercad, modeled this and printed it out. Tinkercad, great question, thank you for asking. Tinkercad is another free software for digital design, modeling, creation of geometry. It's a great program. So this is the platform on the MakerBot that this is still attached to. I teach a variety of classes in addition to working with other teachers. We have exploration classes, and this is for middle school class that we had. And I love giving students goals and then having the lesson be sort of hidden inside the goal. So the goal was, I'm going to point my garage fan at this turbine, and I want to measure electricity with a little voltmeter, multimeter on the other end. Now inside that learning is the actual learning software SketchUp to do the propellers, another level of software 123D, Autodesk 123D, which is a free program you can get. You can do it at home, you can do it at school, for the little nose cones, and then Tinkercad again for the stands. And you give the student the motor, and at the end of the class, the trimester class, you measure the electricity that comes off the motor. But inside of that, packed in is, they've learned 3 levels of design software. But they like that at the end of that. So, again, questions at the end? Great.
Hey, my name is Steve Westwood. I have the privilege of teaching at the Nueva School. We've been doing design thinking. Sort of design thinking is our lens on Makerspace projects. So the idea is, how do we prepare students pre-K through 12 to not only solve problems, but to identify the underlying problem in the context that it's in, to create sort of criteria for success, and then move those projects through. Where we've been doing this for a while, we have a lot of different connections, whether that's computer science, which is really good for integration, architecture, which is really motivating for a lot of different students. There are a lot of different ways that it can branch off. I'm going to talk about 3 different projects just to give you a flavor for a bunch of different ways we can do this. The first one is a project we do in integration with the first grade classroom. And it's just a pasta bridge, only different. So the idea is that the first graders come up, this project goes 2 hours, 1 hour 1 week, and then they come back and do a very similar thing the next week. And when the first graders come up, we sit them down and say, what is a bridge? What is a good bridge? What does a bridge need to do? And the students create a criteria for success. They say bridges, they should not fall down. They should be strong. Boats go underneath them, cars go across them. And they'll develop a longer list with other things quite potentially. And then we'll say, okay, you've got lasagna, you've got spaghetti, you've got 2 tongue depressors, you've got some masking tape. You can rent some more masking tape with math facts. Can you span on these kiddie pools? We've got 6 different stations. Can you span from this edge to this edge? And then every group eventually gets around to spanning it because it's not that hard, and then saying, okay, how tall is the tallest boat you can get underneath? Or what's the next thing you want to do? Are you trying to make your bridge more earthquake safe? And the students will identify and realize that engineering and design projects aren't a binary thing. You haven't either solved a problem or not. You've iterated on existing ideas and moved into interesting ways. We reflect on that, and then they come back in a week later and do the same thing. So integrated into the class, taking a small slice of design. In 6th grade, we take on a lot of new students, and we run a project that's its own class taught by an iLab teacher, so different kind of thing, called Health Innovations, where they identify someone in their community that they know, that they can interview, that they can observe, they can talk to, who has a challenge around health or a medical issue. And through interviewing, through secondary research, through facts, they figure out the problem space, and they say, knowing that we can't cure cancer in 16 hours, what are things that we can do? And they'll think of at least 3 different sort of areas they can help, needs and opportunities. And then choose one of those, generate ideas, and they don't have to be able to build them, because the semester ends with them giving a Shark Tank style pitch saying, for type 1 diabetes, based on my observations of my cousin, this is what I think we need to be able to do. I have proposed this thermoelectrically cooled package so that their insulin can be kept at the right temperature and they don't have to worry as much when they go hiking. And I think you should get with me on this. And we say, yeah, and a lot of the time you don't need to know how to build that idea, because your next step is to go hire a bunch of people who can work with you and help solve that problem. And then the third one I want to quickly mention is a high school elective, because electives are great too. Letting people choose is really powerful, where we're simultaneously reverse engineering bicycles, taking them apart, cleaning them up to donate, running bike repair clinics, so they get all of this mechanical exposure, and at the same time they're doing an open-ended design project of how to make the world better through the lens of bicycles. So one team of students is looking at, for our light rail, how can we make it easier to get bikes unloaded quickly and unloaded at rush hour, and store more bikes so more people can take bikes on the train. Another group of students is looking at how can we make parts where the wear is evident, so somebody who's a novice bike repairing person can look at it and go, that chain is bad, and I should do something about that. It might be take it to a bike mechanic, it might be fix it myself, but how do I know? So those are 3 examples of different ways and entry points that we have across different grades. Thank you.
And I'm a computer science teacher at the Nueva School. And I just wanted to give you a few examples of design thinking through the lens of computer science in case any of you have programs that you are developing. So with our computer science program, we tend to try and weave in the design thinking process, and most of our classes are integrated into other classroom core subjects. So in 4th grade, they're using Scratch to simulate catapults that they are building and designing in their 4th grade science class. In 5th grade, our 5th graders read a book called Seed Folks, which is about a community garden in inner city Chicago, and they developed a Seed Folks Connection website where each student had a written piece about a character in the story and had to link every other character in the story to the other one. And so as they developed their web pages, they had this whole site that was about the book, that was a connected website. In 6th grade, our students are developing their own e-portfolios by learning HTML, CSS, and JavaScript, which is integrated to all their classrooms, math, science, humanities, art, etc. And then in 8th grade, we do a big project where our 7th and 8th grade students either 1 year study the Silk Road or the World's Fair. And this year, the 8th graders with the World Fair project, for their country, they had to come up with a social justice campaign for that country. And so they built websites for fictional nonprofits to get people to act on those campaigns. Thank you.